Section 10.5 is on base E and natural logarithms. Okay, so it says in section 10.1 we talked about the formula A of t equals p times 1 plus r to the t, and we used that when we were determining interest. P was your initial amount, r was your rate, and t was the number of times we compounded. But banks actually don't use that formula, so they kind of trick you. So when you guys get your bank statement, do you usually see how it says, I don't know, do you guys have a bank account? You guys looked at me like I'm crazy there. Like it will say that you get like 1.3% interest monthly. So you're like, wow, if I had $100, after a month, I'm getting $1.30. So that's pretty good, adding $1 each month. But that's not actually what's happening. When it says monthly, that means that it's compounded each month. So what they do is they take your rate. So if it was like 0.13 or 0.013, and then they divide by the number of times. They divide by 12. You don't have to draw this. So that means that you're not really getting 0.013 added. You're getting 0.013 divided by 12. So it's not very nice. So they're kind of tricky like that. So let's talk about this formula. This formula is one you need to know. T is the number of years. N is the number of times compounded per year. So if I said monthly, N would be 12. If I said quarterly, that means 4 times a year. If I said annually, that means once a year. Okay, so number 1, it says determine the amount that a $10,000 investment is worth in 4 years. If it has an annual interest rate of 8%, so R is 0.08, N is compounded annually. So if it's annually, N is equal to 1. P is 10,000, T is 4. So it means 1 time each year. Okay, so my formula is A of t equals P times 1 plus R over N to the NT. So my initial amount, my principal, is 10,000. I have 1 plus 0.08 divided by 1 time a year, and then I have 1 times 4. That's my amount after 4 years. Okay, so be careful about how you put this into your calculator. I'd probably do the 0.08 divided by 1, which is 0.08, plus 1, so 1.08. Then I'd raise it to the 4, and then I'd take that answer times 10,000. So everybody try that. You should get $13,604.89, round to the nearest cent. Okay. How about quarterly? So quarterly, N is no longer 1, N is 4. That means 4 times a year, so every 3 months. So your amount after 4 years would be your principal, so 10,000, times 1 plus 0.08 divided by 4. So it's really like you're getting 0.02. Yeah?
Is it raised to NT or RT?
NT. That's N there. So what the NT part ends up being is the number of times total that you've compounded. So total number of times compounded. Kind of sloppy. So 4 times each year for 4 years would be 16, right? So that's what that's going to end up being. All right, so I get 10,000. When I do 0.08 divided by 4, it's 0.02. Plus 1 is 1.02. I'm going to raise that to the 16. I'm going to take that answer and multiply by 10,000. So 1.02 to the 16, and then times 10,000. So on that one, I get a little bit more. I get 13,727.86. So the more often you're compounding, usually the better, because it's adding that much interest more times. Okay, so we get that. Okay, let's try the next two. So next one is monthly and then daily. So how about from Logan over? So you guys do recording? You guys do monthly to the left side. You guys over do daily. So see what we get. I'll go ahead and do them up here too. Everybody every year always asks, should I use 365 or 365.2524? Do you guys know what they're talking about? Leap year, like you add in leap year. So just use 365. So for this first one, I get 13,756.66. And the second one, I get 13,770.79. Did you guys get those numbers? Okay, good. All right, so it's getting a little bit bigger each time. So you would think that if you compound it every minute or every second or even every nanosecond, that it would be a really, really huge number. It would be like $1 million. All right, but that doesn't actually happen. So it says if we kept going, one would think that the $10,000 investment would grow really large. However, there's a limit to how large each of these dollars grows. So suppose we start with $1. Your annual rate is $100 or 100%, and we keep increasing the value of n as shown below. So look at your table. So that means we'd have 1 as your principal amount, so it's like there's a 1 out front. We have 100% for our rate, so as big as it can be. And then NT, number of times, is going to change. Your time is after a year. Okay, so we're just going to plug in. So this first one I would have 1 plus 1 over 1 to the 1. So that'd be 2 to the first power, which is 2. Okay, then do the second one. So the second one is 1 plus 1 over 4 raised to the 4. So when I do that, I get 2.41 or 441. So somewhere around there. All right, how about left side you guys do monthly, right side you do daily, and then I'll do every minute. So you guys find all of those values. Round to 3 decimal places too. Okay, what'd you guys get for 12? Let me get 12. 2 point what? 613? Okay, what'd you guys get for 365? 2.7 what? 2.715. And then 5,200 or 525,600. Reminds me of the rent side. You get 2.718. Okay, so then you could do every second, you could do every millisecond, and so on. So it says the maximum amount of a $1 investment is approximately 2.72. So $2.72, no matter how large your n is. So it's going to approach this number. So this number E, it's kind of like pi. It's a number that goes on forever and never repeats. And it's a number that occurs very often in nature. So we call it the natural base. So when we take the log with this base, we call it the natural log. So Mr. Napier always talks about natural log. So the guy that invented logarithms, his last name is Napier. So it was originally NL, Napier's log, but they changed it to LN. So I always thought it was just French. You guys know how in French, the language, you guys always pronounce like adjectives after. So I thought it was log naturel. I can't pronounce it, but I always thought that's what it was, but he told me it used to be Napier's log. Okay, so it says when things are compounded continuously, we use the formula A equals P e to the RT. So it's the Pert equation. So it says your amount after time t is your principal times this number, e, this natural base, raised to your rate times time. If r is positive, then it's growing. If it's negative, it's decaying. Okay, so let's see with this natural log. So if I have natural log and e, natural log is just log base e. So do you guys remember when we first learned logarithms, we said if I had log base 5 of 5 to the 11, what was my answer? 11. It's like the 11 went to the front, log base 5 and 5 cancel, they become 1. So it's just 11. So what's this answer? 0.15t, right? That's it. So if I see log base e and e next to each other, so in other words, natural log and e next to each other, I can cancel. Now in this next one, I have e raised to the 3 natural log of x plus 1. So they're not right next to each other. So what about that 3? Can't divide it out, no. Do you guys remember when we had like 3 log of 2? What was that 3 out front?
Oh, it was the exponent.
Yeah, you could pull it up as an exponent. Same thing here. If I have 3 natural log of x plus 1, that's e times natural log of x plus 1 to the 3. I pulled it up as a power. So you can go back and forth like that. Okay, now e and natural log are right next to each other, so it's kind of like when you guys saw 3 to the log base 3 of 15. You can just say it's just equal to 15, right? Same thing here. So the e and natural log cancel. So I'm left with x plus 1 to the 3rd. And that's your answer. Okay, a couple different ways for this one. So when you see 2 logarithms separated with addition, do you guys remember what you can do to combine them? Yeah, multiply. So it's natural log of e to the 2x times e to the x. So it's natural log of e to the 2x times e to the x. You add your powers. So it's e to the 2x plus x, so 3x. So now I can see natural log and e are next to each other. It's just 3x. So your answer is 3x. Okay, let's try an easier way though. Natural log of e to the 2x, what's that? Just look. It's just 2x, right? What's this one? X. 2x plus x is 3x. Much easier that way. So I'd probably do that way. All right, and the number 4, it says, what is the total amount for an investment of $500 invested at 5.25% for 40 years compounded continuously? So whenever you guys hear the word continuously, you always use the Pert formula. So when you see continuously, you use your amount after time t is equal to p e to the RT. So p is 500, r is 0.0525, t is 40. Okay, so we have all the different things we need. So my amount after 40 years is p, so $500, e, so e is a number, kind of like pi, raised to the r, so 0.0525, times t, times 40. Now notice how I wrote that with 2 parentheses like that? If you put it into your calculator exactly like I wrote it, it will mess up. What it will do is it will do e to the 0.0525. It will take that answer and it will multiply by 40. We want all of those to be exponents there. So here's how I would put it into your calculator. So I would have the 0.0525 and then I do times 40 like that. So all of it's in parentheses. So that's all the exponent. Okay, so go ahead and put that in. So check to see if you get the same thing. So I got $4,083.08.